Oh my gosh, everybody. It looks like we are actually finally live here. I apologize for anybody who's just joining, but had a little bit of technical issues there. We're starting 10 minutes late today. But let's get right into it. I'm going to have to go through my spiel again. I was just streaming. I'm getting used to OBS Studio, but yeah, apparently I was streaming but not broadcasting. These are the things that I really got to get used to. Okay, so guys, today we're going to be looking at realistic audio in Unity 3D. So I'm not going to claim to be some audio mixing expert. I took one audio engineering course in high school. It was a lot of fun, but that's not the purpose of today's stream. I simply found a really cool way that we can make our snowstorm sound in our level. It sounds slightly more realistic. So that's what we're going to be working on today. The way that we're going to be doing this, if we come into our environment audio, is with this component called an audio low-pass filter. So this audio low-pass filter essentially cuts off frequencies that are higher than this number that you have right here. So currently it's set at 5007, but when we start the game, it's going to jump to 22,000. That is the absolute maximum that you can have. And that means that no frequencies are going to be cut off. So that's what we normally want when you're outside, right? We don't want to be cutting off any frequencies from the storm. But when you're inside, we want to bring that down so that the high frequencies are being cut off. And it sounds like the storm is outside, kind of like when when there's music playing in the other room and you can't hear the higher frequencies. So let's go ahead and give an example of this instead of me just chatting away. Let's see right here. We're going to scroll down, and I'm actually going to turn off this script right here. This is a script that we're going to be working in today, and it's one that I recently created, but we're going to turn it off for now just so I can demo to you guys what this low-pass filter sounds like. So we're at 22,000. That means that no frequencies are being cut off. But if we bring this all the way down, here you can hear that some of those higher frequencies are being cut out, a little harder to discern. Well, let's drop it all the way down here. Now when we're like under 1,000 or around that 1,000 value, it almost sounds like the storm is outside, right? So let me re-enable this, and you can see that this jumps up to 22,000 because our snow low-pass filter controller is currently always setting it to 22,000 when you're outside. But if we run over to our cabin, grab our lantern so that the door opens. When we come inside, you notice, okay, nothing's changed, right? And even if we walk around, nothing's really changed. And this is something we're actually going to work on today. We're going to make it so that this low-pass filter works when the door is open, but you are sort of far away from the door and there's walls in between you and the door. But what I did implement is that if you're inside and you close this door, it's going to change the audio so that we get that outside low-pass filter sound effect. Okay, so now it sounds a little cooler, right? Now it sounds like the storm is outside. But if you guys probably noticed that if we open up the door, it sounds good. But when we close it, as soon as we press the interact button, the low-pass filter is dropping down immediately to our level, which I think we set to 800. So the first order of business today is actually going to be to change that. We're going to want to interpolate between those 22,000 and 800 values. We're going to want to do it more smoothly so that it actually sounds like you're closing the door and it's not some gamey thing where the audio just immediately changes, right? So let's go ahead and pull up our snow low-pass filter. Let's take a look at this. So I'll start off by explaining a little bit of what's going on here. Here in our start method, this is called as soon as we start our game. This low-pass filter is being set using our get component. Essentially, it takes this low-pass filter component, which is stuck onto our environment audio object, and gives us a reference to it in code. And then down here, this looks a little weird, right? What we're doing here is we're getting our player position from our game manager. Our game manager, which has been set up way in the past. Our game manager is always storing our player game objects, so it's really easy to just grab our position. And this is happening on every frame in our update. But none of these operations are going to be too computationally heavy. So I'm not worried about performance with something like this. So we see that we have two bools, inside box 1 and inside box 2. And this could look a little strange if you're seeing it for the first time. But essentially, this is how we're going to check whether we're inside or outside. So if we come in here, there were a bunch of ways that we could check if we were inside or outside. But I found that the easiest way to do it was kind of to set up my own boundaries. So if you are above 0.5 on the y-axis, as you can see right here, and our y-axis is our up and down axis, and you are inside one of the boundaries that I set up, pretty much just hard-coding these weird numbers in here, then it's going to determine that you're inside. So essentially, like, say this z-value is 2.4 and this z-value is 4.8. If you're in between these two boundaries, you're above 0.5 in the y, and then you're in between these two boundaries here, then you will be considered inside. And I needed to do two boxes because of the way that the house is actually shaped. So we have one box, which pretty much encapsulates this foyer area, the living room, and part of the kitchen at least. And then the other box pretty much takes care of everything that's going on in here. Now, when I started my stream too early and didn't end up actually broadcasting, I did realize that there's going to be a race condition, a little bug, because you can go down into the basement later on in this playthrough, in your playthrough. And once you're inside the basement, this condition is going to evaluate to false for sure. And we are not going to have that inside low pass filter frequency. So we could probably fix that right now. Why don't we fix that right now? First, let's test and make sure that it's actually a bug. I'm pretty much positive that it's going to be, but I kind of want to see what it sounds like just for fun. Okie doke. Let's go ahead and sprint on over to our house. Let's go inside. And guys, we are going to cheat here. In our game, you have to grab this key right here, and you have to run over there, get a different key. I'm just gonna cheat, and I'm gonna skip all the way to the end, essentially. I'm going to just automatically unlock these doors inside the editor, because I have God powers when I'm working on my game. So that door is now unlocked, and this gate is also unlocked. So we can go straight down into the basement. Ooh, big noise. That was actually a little too loud. I might want to bring that down. That could scare the crap out of somebody. No, it is a horror game. Oh, I did something wrong here. I forgot to close the door. Yep, I forgot to close the door, guys. So, remember, if we look at this condition over here, front door is open. So we need the door to be closed, as I kind of showed you before, in order for this to work. Alright, time to speedrun. Let's make sure to close the door this time. Grab our light, go inside, close the door. See, okay, now our audio sounds good. Sounds like we're inside. Let's unlock this bad boy. Let's unlock this bad boy. Cool. And now let's go inside. And we have that loud ass ladder noise going on. I guess it's because... Okay. I'm going to focus that. Yep. And when you come down here, it sounds like you're outside again. Inside, outside, inside, outside. You get the point. So, I think this is going to be a really easy fix. We just need to add another condition here. So, if the front door is open, and this condition or you are less than some value. So let's see where our player is. Our player starts over here. Let's grab our FPS controller. Let's just see where the ground level is for our player. So I'm not 100% sure. It should be a little bit below 0. Yep, minus 0.21. And when you go into the basement, you're definitely going to be several feet under that. Or several meters, I guess, because that's Unity's measurements. So, let's see. This could be one big condition, because when you're inside the basement, we're always going to want to be. In fact, we're going to want to probably set that low pass filter maybe to 0. And you know what, guys? I just realized something. Man, talking out loud to chat, even though nobody's here, it's actually very good for me sort of just figuring things out. I just realized that inside of our environment, this low pass filter is affecting both our atmosphere and our wind loop. We probably just want it to be affecting our wind loop. So I think what we're going to have to do is... Let's see. Audio manager. No, we don't want to mess. This audio manager is essentially for playing one-shot clips. So I think we're just going to want to make another one of these bad boys. So let's go ahead and duplicate this. And let's get rid of the wind. Remove component. And let's remove our atmosphere over here. So we're pretty much just separating these two. It doesn't really make too much sense to have one object for both. So here we're going to call this our snowstorm audio. And then we're going to call this our atmosphere music. Cool. And then let's remove both of these from here, because this should just always be going. Let's see how that sounds, because yeah, it really doesn't make sense that we were doing the low pass filter on both of those there. Let's go ahead and go inside. See if that sounds a little bit cooler. Because it should sound more effective. Ooh, that didn't sound good. What was that? Is it having trouble starting both of them? Interesting. Let's see if we can change that. Okay, that's really weird. So now we're getting a glitch where the atmospheric music is starting with a little bit of a delay now that we've separated these two. That's definitely not what we are looking for here. Oh boy, oh boy, oh boy, chat. Let me look this bad boy up on Google. It's time to Google this. Okay. Unity multiple audio starting with delay. Best latency? Let's see if there's a way to affect our latency. Logarithmic roll-off. Spatial blend should be 2D, obviously. Stereo pan. I'm just gonna click stuff, guys. That's one thing we could look into. Is there just some delay in the start of the music? Let's go ahead and listen here. That's the wrong one. No, it looks like it comes right in. Okay, so this is... See, I don't want to create new problems for myself, you know? That's the thing. So what I'm going to do, I'm going to test and just make sure that this sounds good in the first place. Whoa, look at that lag, everybody. I don't know why our game is so laggy right now. Let's look at our FPS. What's our FPS at? Oh my god, 10 FPS, sometimes less. That is not what we're going for. That didn't happen because of this change, did it? Gosh, am I screwing up everything in my game? Oh, that was not what I wanted to do. Let's put this down here. Just because that's how I like it looking. Still have really bad FPS. But it might just be like that. Yeah, guys, this game, if you didn't know, this game definitely needs some optimizations coming our way. Look at that, we almost get 60 when we're looking this way. And it seriously drops when you look towards the house. And I think that's because of our occlusion culling. If we look here, there's just a lot more on screen. Man, oh, look at all these objects that aren't being culled out. I wonder if they're set to... Yeah, it looks like they are set to static. But there's... I wonder if there's a way that we can bring our occlusion culling like what distance, like way down. So stuff back here definitely shouldn't be getting rendered. The only stuff that really should be getting rendered at this time is like this lamp. And like that's pretty much it. Maybe the house. Gosh. Black. Oh my gosh, I thought that said blackface. Backface threshold. Let's see if we could bring this down. Is that... Set default parameters. Okay, so, gosh, we're getting so off topic. Is this something that we want to look into now? I think what we're going to do, chat, I'm going to put this in my to-do list because I want to keep things on topic just in case anybody is going to be watching and is really curious about this audio stuff. Let's do the audio stuff first. If we have time to figure this stuff out later, we'll do that. But what I'm going to do is I'm going to combine our audio objects again. And we'll figure out how we can separate those two functionalities later. But let me just write down for myself two different things. Separate wind and atmosphere objects without annoying stuff. And then also occlusion culling. I know that right currently, guys, while I'm working, optimization is not exactly on the top of my mind. That's something that I want to get to and really focus on in the last like 1 or 2 months before release. Right now, we got a lot of bugs to fix, a lot of content to make, but this could be something that could really affect our frame rate. So I'm going to say look into bake settings for occlusion culling. And if anybody doesn't know what occlusion culling is, it's essentially just making sure that objects that the player can't see are being hidden. So if you look back here, man, why is nothing being, maybe I don't know, I have to view volumes maybe? No. Visualize, there we go. Oh, actually, okay. So I wasn't visualizing it. This is what is being rendered in the scene currently, but this is still way too much. Like this, we should not be getting this much detail. And if we come into the shed, yeah, you can see that so many of these objects are still being rendered, even though they definitely should not. Like nothing in this shed should be getting rendered at all. Yeah, 15 frames per second. That's absolutely wacky. But guys, that's what we're going to come back to at the end of the stream. Or at least once we've figured out this audio stuff. So let's go down to our Snowstorm audio. And we're going to put our tail between our legs for now. We're going to add this audio source back. Let's move it up a couple times just because I like consistency. Don't like those. Yeah, this is fun. Dark atmosphere. I think it's this one, right? I'll know the difference as soon as I start playing. No, it's not. Atmosphere. Oh, no, it is 0, 1. Okay, I was wrong. And then we want to do loop, and we want to put this down to 0.5. Okay. We have officially tucked our tail between our legs. We're not going to worry about it for now. And see, I got so off track. I'm like, what are we even doing right now? Literally, what were we doing? I don't even remember. This is not good, guys. Oh, the basement. The basement, yeah. So we literally, I remember now. I literally just hit play so that I could see the Y value of our player. And it was like, yeah, it was right around here. So we can do minus 0.5. So if this condition is met, we're just going to put this OR down here. I don't know exactly how this is all going to be evaluated, so I'm going to use parentheses. So essentially, if the front door is open and the player is inside, or if you're in the basement, it's just definitely going to turn the occlusion culling down. So let's see, or not the occlusion culling, the low pass filter. So we're going to say player position dot y is less than negative 0.5 f. Oh, looks like we have our first viewer. Welcome, welcome. Introduce yourself if you like, and feel free to ask any questions while I'm doing this. So if we're inside the basement, we are also going to put this low pass filter frequency down to 800. So that should now work for the basement. I guess let's go test it out. Make sure to stay hydrated, everybody. Okie doke. Have to take a second for all this to load. Okay, there we go. And we even still had that delay with the environment audio. So weird. We'll have to get back to that. But let's go inside. If you just got here, when we close our door, by using this low pass filter that we put onto our environment audio, it's going to sound like the audio is happening. It's going to sound like the storm is happening outside instead of inside. So if we close the door, yeah, it sounds like it's outside now. And if you weren't here before, yes, I know it sounds really bad because as soon as you interact, this door is going to close. Or as soon as you interact, the low pass filter is going to come on. But it wasn't working when we were inside the basement down here because we were doing this check to see if you were above the ground because the cabin is above the ground. I'm going to cheat here. I'm going to open up this door. This door is locked, and so is this one, this hatch right here. You're supposed to do stuff in-game to unlock these, but I am the god of this realm, so I can do whatever I want. And if we go down into the basement now, as long as we still hear this low pass filter, then we should be good. Yep, sounds perfect. Okay, let's see. Error. Open Studio. I hope we're not getting any issues here because I'm getting some sort of error inside of OBS Studio. Not receiving enough video to maintain smooth streaming. Sorry. There's some buffering that might be going on here. But let's go back in. Looks like we lost our viewer, but that's okay. I'm glad that we got one. Oh crap, I forget that our monster's here. Okay, let's go ahead and start with making sure that we can interpolate between these two values inside of the door, or when we interact with the door. So low pass cutoff frequency. Okay, so this is looking all good. What do we want to do here? Essentially, as soon as we start closing the door, we don't want to immediately go to 800F. We want to interpolate between this 2200 value and what we want next. So we're gonna be learning as a group here because I have never understood math.lerp. It's something that I've always struggled with. But let's see. We're gonna say interpolate between two numbers over time. Oh, I got a text from my mom. I thought she was gonna be the one who showed up to the stream for a second. I was gonna be like, not that, Mom. I do want you on this stream. If you ever see this, come watch my stream. But I want other people watching that aren't obligated to support me. Interpolate between two numbers over time. Unity. That should give us what we want. Linear interpolation. Oh boy. The right way to. Very often in Unity, you may want to animate a button. LERP, or linear interpolation, is a mathematical function in Unity that returns a value between two others. Oh, this is a long article. Most commonly, it's used for moving or changing values over a period of time, which is exactly what we want to do. It's an incredibly common feature of Unity and development in general. Oh, do we have to watch a video? Do I become a reaction streamer and watch this video with you guys? No. First thing that you need to know about LERP. Okay, I know how LERP works. It's basically just a calculation. And there's this A, B, and T value. A is where we start. B is where we want to go. T is the time. So it's like how far along you want to be. But how do we do this over time? The right way to LERP. Create a timer, incrementing it every frame of the LERP. Divide the time elapsed by the total duration of the... Oh, that makes sense. pass in the value as the interpolation point t. So we want to go from 2200 down to 800. And then we take our total time that we want it to take to close. So that should be about a second or so. That's how long our door close animation is. And then, yes, so we want that point along the curve. Okay, this makes sense. Let's take a look at here what this guy's doing. Yeah, mathf.lerp, start value, end value, time elapsed divided by lerp duration. Time elapsed plus equals time dot. Yeah. Yeah, this is what we want. This is what we want. Is there any way? Okay, so what we could do is we could get the we could try and find a way to get the actual length of this door closing animation. But honestly, I'm gonna cheat here, guys. I'm gonna fudge the numbers. It should be about a second. So here, instead of going straight to 800, what we're gonna do is we're gonna cheat again. We're gonna look here. mathf.lerp, start value, end value, time elapsed. So we're gonna say our start value is, well, first let's say mathf. Is this our, yeah, it's automatically imported. .lerp, so linear interpolation. I think that's what it means. I don't know why there's an E, but mathf.lerp, float A is our start, so we're going to say 22,000. That's our maximum value. I like to put this F just to show that it's a float. We probably don't want the comma there, though. 800, that's where we want to go to. And then T. T is going to be our time elapsed divided by our door close time. And that's a value that we're just going to set over here somewhere. Private. Yeah, let's put our constants up here. Let's just call it private const door close time equals 1 second. Float, we need to float. And then our time elapsed. So our time elapsed, we want to start out at 0 and then go up as soon as we do this. Yeah, so what we're going to do here is we're going to, inside of start, we're probably going to set this. We're going to put private float time elapsed. Inside of start, we're going to set this to 0. And then down here, this should have an F. Down, so should this, and so should this. Let's be consistent with our code, everybody. Be consistent coders. Okay, so time lapse is 0F. Yeah, and then we want to go down here. We want to say time elapsed plus equals time dot delta time. So this time dot delta time, no, we don't need it's not a method. It's just a parameter, or not a parameter, a property. So time dot delta time is just the time since the last frame. So essentially, every time that this frame runs, it's going to add the time since the last frame. So we're going to get the time elapsed. So low pass filter, time elapsed divided by door close time. Is there anything that I'm missing? Oh, well, down here we're going to want to reset the time elapsed when we are not outside, I guess. How can we reset this time elapsed? Yeah, we what I was just thinking we need a conditional out here. So we're gonna say if time less than door close time, then we're going to do this. And we're going to have to reset this time elapsed somewhere. Does he reset it? Probably not. It's really nice when you can just steal code from people, you know? This else block makes sense. I'm gonna... Oh my gosh, I'm just stealing rate from this guy. Float time lapse equals 0. Time lapse is less than lerp duration. You can use a coroutine. Sure, why not? I don't think we need a coroutine though. Oh my gosh. You know what? This this one actually looks pretty good. We might want this smooth lerp. Oh, wait. Smooth lerp. Isn't there literally a function called slurp? Gosh, this is a lot. Oh my god. I didn't even notice this bar over here. Holy crud, dude. Okay, it only goes down to like 2/3 of the way. But this is a long article, and I definitely don't want to just sit here watching this or reading this on stream. That's something for me to do on my own. Mathf.slurp. Lerp versus... Isn't there... I'm pretty sure... Yeah, lerp versus slurp. So this is a linear one, this is a smooth linear one. I think we want the smooth linear one. Let's try the slurp. Let's just put a friggin' S right on there. Let's call it a slurp. Nope, that's not how it works. I thought we could just say mathf.slurp. Vector3.slurp. Why is there no... Is there a math.slurp? Smooth step? Slurp versus smooth step. What is the difference between those two? Oh my gosh, this is so complex. See, I knew that we were gonna get into this. I hate lerping, I hate slurping. Minimum, maximum time. I think we can just use this smooth step. It might look better. You know what? Why don't we start off with the lerp? Let's hear how it sounds. Let's put a comment for ourselves though and say, try out mathf.smooth step. Might sound better for the door. Excuse me. What I'm thinking right now. Oh my gosh. Excuse me, guys. Drink your water, but drink it slowly. Holy crap. All right, else. let's set our low pass filter dot cutoff frequency equal to 800F, and we might want to make that a variable since we have it two places in the code. But yeah, let's do good code here. So private const float. We're gonna call this. What are we gonna call this, guys? Poop. Poopy poop poop poop. No, that's not what we're gonna call it. We're gonna call it. We could just call it outside cutoff frequency. Yeah, that sounds good. Equals 22,000 Fahrenheit. Inside frequency. That's just a little cleaner, guys. Probably better ways to do it still, but you know, like, I don't know. It's like create a like straight like a numbers utility class, but we're not going to do that. That's crazy. So we're going to call this outside. We're going to call this inside. And we're going to do the same here. And we're going to do the same here, outside. Okay, that's a little cleaner. So time elapsed divided by door close time, and now we just have to reset the time elapsed once you do that, but we want to make sure that this also isn't just happening all the time, you know? So there's ways that we can do this with just like adding in random booleans, but I always feel so dirty when I do something like that, you know? I think we're going to have to do it that way, though. So we're going to say door closing. Yeah, we're going to have to create a private bool. So this is just going to tell us if the door is in the act of closing, right? So private bool door closing. So, and then we're going to say here, if door closing. And so essentially there's going to be this time where we're either going to have a full inside cutoff frequency, or we're going to be lerping it. We want to be lerping it when the door dot closed is true, or well, the door dot open is false. And you're inside, right? And the door is in the process of closing. How do you figure that out, though? So I guess you know what? I think the easiest way we're gonna try and just do this the easiest way. This is getting pretty complex. Whoa. Sorry guys, I think I lost connection there for a second, which is weird. My Wi-Fi should be fine here, you know? Okay, I think we're good. So if the door is closing, and what? And the door is open. Oh, this is really complex, because what if they try and... Oh, actually they can't open the door when the animation is playing, which is really good, because the collider actually turns off, I think. Yeah. So we're good there. We don't have to worry about that. So if door is closing and door dot open, right? Front door dot open. No, this is crazy. Door closing and I feel so dumb right now, guys. And I feel like I'm under pressure because I'm on the live stream. I feel like I would figure this out way quicker if I was just doing it on my own. But I need to get used to that, you know. Okay. Let's focus up. I might have to stop talking for just a second, guys. So we could say here, door closing equals false, right? Because this is when it stops closing. And on top of that, if the front door, if door closes, so we also want to say up here something like if door closing is false, or if not door closing. Yeah, so if the door is not closing and the front door is set to close, then that means that the player just closed the door. So we want to say if not door closing, oh, this is so confusing, guys. When do we want to reset all this stuff, you know? I feel like I'm just making this way more complex than it needs to be. Low pass filter dot cutoff frequency is outside cutoff frequency. So that's when it's open. Maybe we don't need this. Maybe if you open the door, then we do something. So we want to start closing. We want to set this door closing equal to true whenever whenever the first call of this happens, right? But not after that. So we need some sort of flag. And it should stay closed until this is called. So this is the flag that we need, right? No, I started stuttering there. Sorry, guys, that was a little insensitive. But I don't usually stutter, so that was a little weird. Okay. Then we set it to true. We set it to true in here, which is stupid. This is probably a bad variable name. This is probably very bad code. We set door closing equal to true in here. We also want to set door closing up here. That actually might do it. And then No. That was the wrong place. We want to set door closing to false here. so that it's not going to be doing any of that crazy stuff inside of there. And then inside here is where we reset our time elapsed. Whoa. Oh my gosh, guys. Brain dead today. We set time elapsed equal to 0. So now this is going to be false until you open the door, right? False until you open the door. Yeah, and then once you open the door, no, we need this to be true. So you open the door, it's true, and then yeah. So can we rename this so this isn't so confusing? You know, we could say just like closed door. You know, like, or door can be closed, you know? Yeah, I like that. Door can be. Oh well, we can actually use some fancy dancy. Visual Studio magic here. We can just go ahead and rename this. Door can be closed. So that makes sense. So when you are door can be closed. I like that. So when you're in here, or door close animation ready, maybe? Because this is almost part of the animation, you know? Door close animation ready. That's actually an interesting one. Maybe we call it that. Yeah. Let's call it that. Door close animation ready. See, I like that because now what we can do is, so door close animation ready is set to true at the start. We don't actually need to do that though, because this is going to be set down here. I'd rather that be set in code down there. But what if you're like on the other side of the door? Is that going to not work? It should work though. It's just so hacky, you know, because if you're say you're outside, this is going to evaluate to false. Door close animation ready is going to be true, even if the door is closed already. You know, you open it up, but this is still going to be false. So it's gonna work, I think. I'm just gonna try it. Sometimes with code like this, when it gets so complex, you just gotta shoot for the moon, you know? Oh boy, okay, let's go. Okay, let's make sure. Wait, nothing crazy happened when we opened the door, which is good. Nothing crazy happened when we stepped inside. This is making me sad. I know that my game runs poorly. That sounded pretty good, right? You know what the funny thing is? The funny thing is, let's take a look at our environment audio. Let's take a look at our environment audio. let's turn this off and let's listen. You know what? It's not gonna work. I think it sounded a lot better, but that's also because it's kind of weird with the cutoff frequencies. When you're up here at 22,000, it feels like there's barely a change. Till around 5,000 maybe? I'm trying to listen closely here, guys. There's essentially very little difference. Like, maybe a little tiny bit. But there's very little difference between that, like, 5,000, maybe like 6,000 or 7,000 mark. So maybe we started off at 6,000? Try something like that, you know? Let's go out of here. So on this first frame, we want to set it to. Oh, well, actually, no. We don't need that. What we can do is instead of lerping from this cutoff frequency down to inside cutoff frequency, we can add another variable, which is fine. It's fine. I don't care. Private const float. Close enough? No. Door close, start cutoff frequency. Starting cutoff frequency, maybe. And we're going to say this is like 7,000. Or maybe 6,000. Let's do 6,000. Oh, don't want the double equals sign. It's not a comparison. So we're going to do that. That should work. I think that should sound a little bit smoother. And you know what? We should look at the audio low pass filter over here next time we do this. It'd be kind of interesting to just take a look at it. Okay, so it's at 22,000. Grab the lantern, you open the door, inside. Okay, that sounded pretty good. Let's try it with this smooth step. See if that sounds any better. It may not. Maybe we just don't worry about it, but I think it makes sense that the smooth step would sound better because when you're closing the door at first, it's not going to make much of a change. So that's when it's kind of like a low angle. Then in the middle, I guess it's going to be a little bit more intense, and then once you're pretty close to close, it should sound almost there. I think it'll sound better, but I'm not going to, we're making an indie game. As long as it sounds good, like, we can just play around, because I'm no physicist, I'm no audio expert, as I've mentioned before. I think that sounds perfect. I literally think that sounds awesome. And I just want to test something out really quick. This is dumb. But I did actually make one small change recently that I want to show you guys, chat. When you grab this key, we have this guy that starts banging on the door. And I wanna hear the low pass filter start up when you open the door. Oh, sounds so good, chat. I like it. I like it. But I think we actually do want to slurp this bad boy too. But we want the time to be a lot quicker, maybe? No, we don't really need that. Maybe we want to make it linear too, because when you open... No. Let's just give it a try. We're gonna say here... Oh, this might be a little more complicated than I thought. Well, let's start off with our mathf.smooth step. And we're going to say, we're going to start off with our inside cutoff frequency, right? Inside. Oh, I said inside. I feel like I typed that a million times. How did I not catch that? No, I only typed it twice, but still. That's kind of silly. If I had a nickel for every time that I typed inside, I'd only have 3 nickels, but it's still pretty weird that it happened that many times, right? Alright, inside cutoff frequency. And we want to go to the outside cutoff frequency this time. Because we're fine with the quick door open thing. Because like right now it doesn't sound too bad. But we want it to just be a little tiny bit smoother. So we got that, and then we'll say, we don't want to use time elapsed, do we? Maybe we can reuse it. Let's see. Time elapsed. We're just going to go for it, and if it doesn't work out, we'll create a new one. Time elapsed. We're going to say... if time elapsed is less than door open. Yeah. Or we don't need cutoff in there. What am I talking about? Door open time. We're also going to divide this by door open time. Cool. Let's make this a little... we'll make it the same for now. But I like having the option of changing that later, you know? That's why we make it a variable. Or a constant. Okay, we got that. We want time elapsed plus equals time.delta time. Cool. Get rid of this comment. So door close animation red equals true. Are we gonna have to do something similar here? Maybe. Maybe we do. Maybe we do. I wonder if we can just like pretty much copy what we did up there and just say private bool door open animation. Ready? Come down here. We set this to true here, so let's just see if it works, you know? Door open animation ready equals true. Yeah, so The door open animation is going to be ready once you start closing the door. It doesn't matter if it's open while the door is closing, because you can't interact with doors while they're closing. So that saves us, right? And then let's see if we... So... Door open animation ready equals true. So we also want to say if door open animation ready equals, oh, well, we don't need to do equals true. We can just do that. Else. So that means that this is going to evaluate to false at some point. So then we're going to say door open animation ready equals false. Right? Yeah. Low pass filter dot cutoff frequency. So we're just gonna make sure that we're set to 22,000 correctly, right? Equals outside cutoff frequency, and then we are gonna say time elapsed equals 0f. That might work. Let's just try it again, guys. Just shoot for the moon. Don't make unit tests. Don't do like a logical pass over of your code. Just run it. That's how we roll. Close sounds good. Okay, so I think I would still like a little bit of leeway there. I did notice a little bit of a jump right here with this door closed starting cutoff frequency. So I think you could probably afford to make that like 8,000 and it would still sound pretty good, right? Yeah, let's try it. If it doesn't sound good, then we'll come back. But I think we're going to go from inside cutoff frequency to this doors. We don't want to call it that. We want to call it rename. Door closer. Door smooth cutoff frequency. We're going to call it smooth outside cutoff frequency. So it's going to sound very similar, but it's going to be closer to that number. So mathf.lerp is working how we need it to, you know? So we're going to do that at 8,000F. We're going to go to outside. No, we called it smooth outside cutoff frequency. And then we're going to and then we're going to jump up to the outside cutoff frequency. So let's hear how that sounds. And the reason I did that, I don't even know if I explained myself there. I was just listening, and I think that even though it's a little less awkward when you're opening the door, I think it could still be a little bit smoother. I'm a goober. I don't know why I accidentally unplayed it. Okay, let's roll. That's awesome. I like it. I think it's beautiful. I think that sounds awesome, and I think we are done with this section, guys. Woo! We did it! Nice! So if you guys remember, we still want to do something with the door when it's open. We want this low pass filter to be kind of working when we're all the way over here. And the way I was thinking we do that, well, there's two ways. We could do things a little more programmatically with like seeing if you're behind a wall. That's definitely possible. Or we could do it so that we turn this 3D blend over here, the spatial blend, we turn this all the way up to 3D when the door is open. That way we can use this low pass filter and kind of mess with it. We can mess with this curve. You know, we add another point over here. Wait, can we? Can we? Can we not? What the heck? Add key. Whoa, you can't... Okay, so now we know how we're going to do it. We are not going to do it. I thought that this would work like all the other types of stuff does here. Like here you can just, you know, double click and add something there. But apparently this low pass filter you can't really mess with that much, you know? Which is a shame. But okay, we're going to have to do things programmatically. We're going to have to calculate probably a combination of the distance to some sort of algorithm for the distance to the door in combination with how far you are. So like, yeah, you can't see the door right now, but like you're right there, you know? So we could even have it so like rays would bounce off and we see if we could bounce to get it. That sounds like it could maybe get a little awkward. But we'll find some sort of solution here. But guys, before we get started with that, I'm going to use the bathroom. I'll be right back. Okay, chat, I'm back. Now, something I want to do before we start back up work with our next task. I am a little pissy that we weren't able to separate the snowstorm audio and the atmosphere audio. So what I want to do is I want to just test and see. Let's just disable this audio source over here so that we can come back to it without having to delete anything. Let's remove this component. Let's remove the low pass filter. So I just want to test it and see what it sounds like when we are only doing the low pass filter on the snowstorm sound, the snow storm sound. Yeah, it's so weird that there's that delay. I don't like it. Don't like it at all. FPS is through the roof. Like, logically, it makes sense that we do it this way. You know? It doesn't sound all that bad either when we... Because, I mean, it's... The dark atmosphere is mostly low frequencies. You know what? Let's go ahead and let's uncheck our snow audio and see how... Yeah, it does sound pretty different. Okay, so I think I like it with the two separate. I think we're gonna try and figure that out later. So let's come back in here. We're gonna call this atmosphere music as we did before. I think I want to bring the music down just a touch too. Maybe like 0.35 or not 0.35, 0.45. Let's try that. So we got that, our dark atmosphere. We'll leave that unchecked for now just in case we ever want to come back and tuck our tail between our legs like we did before. Let's give this one more try. Just one more try. Make sure that everything's sounding good. And I'm wondering if it's like a glitch in the Unity editor. Like, I'm wondering if I make a build, if there's still going to be that delay. Like, probably, right? But who knows? There's no way that this would help our FPS, right? We shouldn't be affecting. We're running at like 19, 15, 13. Yeah, I know it's super low, guys. We're gonna work on it, I swear. Yeah, it's not affecting it. That would be silly if it was. Yeah, the music should not be affected by the low pass filter, that's for sure. So let's move on to our next task. Let's see. There's really no way to actually do 3D sound, even though it makes it seem like you should be able to with this low pass. What? Oh, maybe it was just when we were in play mode it wasn't letting us do that or something. So that's good. So if you're inside and you're super duper far away, we don't want to be able to hear it. So this is in meters, I believe. Yeah, meters. So if you're like you're like 20 meters away, we probably want to have a pretty big one. Wait, but what value is this? I can't even tell. That's awkward. They're not giving me a read on, like, what the Y value actually means. Oh, you know what? Maybe this is like percentage of maximum. So 800 would be like, let's just pull out the calculator. I'm not doing that math. We need 800 divided by 22,000. 0.36. Nope, that was very wrong. 800. Nope. Oh my god. 800 divided by 22,000. 1, 2, 3. There we go. Yeah, so it's about 3.5%, which is pretty close to where we are. So do we really want to use this, or do we need to make it more complex, you know? Is this worth our time? That's the question, chat, you know? So when we're super close, we want to be up at 1, that's for sure. So, and if the door is open, let's just put this in a different part of the code. We don't want to mess with this, you know? We're going to say if front door dot open and you're inside, which is already what we were looking at, right? No, it would be down here. So if front door is open and you're inside, or the player is less than 0.5 if. That would just value it there. Yes, we're good there. So that means that down here we're going to say the door's open, right? We're going to enable 3D sound. So, I guess we need an audio source, right? We're going to say private audio source. Audio source. We're going to get it on start. I guess we technically maybe should be getting it on awake. Who cares, right? Who cares? Okay, and then we're going to say down here, audios. Oh, wait. We don't want 3D sound when you're outside, though. We want 3D sound when you're inside and the front door is open. Oh, boy. Let's move this all into... Let's organize this a little bit more. We're going to say bool inside equals this. That's our inside Boolean. So if the front door is open and inside, or if the front door is closed and you're inside, then we're going to do that. Yep, we're just going to do that. Whatever, who cares, right? Then we're going to set our audio source. You should be able to just set that, right? Oh, split. It's called spatial blend. So we want 3D sound when you're inside the house and the door is open. Otherwise, it's going to be completely two-dimensional sound. And it shouldn't matter when you're super close to the door. Like, we don't have to smooth anything when the door is closing because you're going to be right there. The 3D sound isn't going to be making that much of an effect. We have a syntax error, everyone. That makes sense. We just don't need this one right here. This ain't Texas, this ain't no Hold'em, so lay your cards down, 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 down. Let me know in the comments, guys, what you think of Beyonce's new country song. Okie doke. Let's see if this did anything, you know. We should be able to see once that 3D sound is turned on. Right, spatial blend is 1, spatial blend is 0, good, good. And then if we zoom super in, we make sure that we can see our spatial blend. We see that it's doing nothing. What the heck? That's because this is always being set, huh? You know what? This stuff only needs to happen once, right? So what if we said else if? That might do it for us. So this won't always be getting run, which is probably a good thing overall. Starting to get hungry, chat. I was supposed to have dinner sometime between 5 and 6 after I stopped working and before I hopped on here, but I could not find my wallet for the life of me. I was about to burn the entire world down. I was angry. Okay. So let's roll in here. Let's look over this way. And we see that this is not how we wanted it. Let's just look at our spatial blend because this is getting a little confusing. Oh, and you know what? We're gonna have to move this snowstorm audio over top of the door as well, for sure. We'll make that look a little prettier there soon, but that's fine for the time being. Okay, so we added a key there. When you're close by, oh, and the door should be open right now because we are still on 2D, I guess. 0 should be at 1. Whatever. Come on, put it at 1. Oh, that's gonna drive me crazy. Put it at 998, whatever, who cares? Okay, and then when you're at about 18 meters maybe? Ooh, why is it always being set there? I thought we fixed this. I thought we fixed this. Why does it look like it's... Huh, so I guess you can't change the... Can you not change the thingy-mahoob? Let's see if this is constantly being set still. No, it's not. Yeah, so it just, like, changes our curve. It just changed our curve, like, when we set the stuff. That sucks. I guess it makes sense, though, because if you're in... Yeah, that's tough. This might not work out how we want it to. I might just want to do things programmatically. It doesn't seem like Unity's tools are super intuitive here. Oh, this kind of sucks. This is harder than the first one. First one was easy. So I could make sure that we're in spatial blend of 0 until we're ready to use that stuff. We could give that a try, I guess. So, like, down here, this is what happens when the door opens, right? Yeah, it's when the door opens. So we want to say that after the door is fully open, now Now we want to set it to spatial blend equals 0. Or spatial blend equals 1. And then maybe we just say, like, if you're not inside, like, spatial blend 0. Just immediately spatial blend 0. So once the door is open, it turns on spatial blend. If we close the door, when we start, I guess when we're finished closing, we can, or no, is that going to affect our curve? That might affect our curve. So instead, as soon as we start closing the door, then we want to set it to 0. So it'd be something like, yeah, this might not work. I don't know. Audio source dot spatial blend equals 0f. And then we affect the frequency. So essentially by doing this, we're never changing the low pass filter value unless the spatial blend is 2D. So that way, hopefully, we'll be able to keep our curve. Whoa. The cutoff frequency is being controlled by the curve right now? Why? Oh, why? Oh, why is it doing that when we don't have spatial sound? Is that only for volume? That's craziness. Wow, that's absolutely nutty. Okay, chat. So this definitely isn't going to work. We can't even turn off the curve. That's absurd, dude. There's no way to turn off the curve. I mean, I guess let's look it up and see if there's something we can do. But at this point, I just want to do it programmatically, you know? I want to have more control here because this has been such a pain in the butt. It's called low pass filter. What am I looking up? Yeah, I didn't think so. Nobody's gonna have this exact issue. Yeah, nobody's gonna have this issue. Unity is being real sucky here, so you know what we're gonna do? We're gonna scrap this whole idea. we are going to scrap it. Bam, bam, bam. Pain in my butt. Get rid of this audio source. We don't need it. We don't need it. We don't need you either. Or you. Okay, so we're going to do this ourselves. We are going to do this ourselves. So, when we're inside... Maybe we check like how many layers of walls there are between you and the door? That's crazy, right? Oh, this is complicated. We find the distance. This is really complicated, guys. Yeah, so before I was thinking like, we see how many walls are in between you and the door, which is certainly possible. Maybe we just do it with like one wall. Yeah, we just raycast between the player and the wall. Or between the player and the door. Yeah. Let's just try that. Excuse me, guys. We start off with... So, here's a little bit of game dev philosophy that I've... So, guys, here's a little bit of... If you guys notice, I want to clip this for later. So, guys, here's a little bit of game dev philosophy that I have here. You usually want to start off with a sort of minimum viable product. Not a minimum viable product. What are we looking for? What's the word I'm looking for? Like, there's a book that I read with this. Let me go find it. Cracking the Coding Interview. This is a good book if anybody's trying to get into the software industry. Let me see. It should be in like how to solve problems, essentially. Shouldn't be in Big O. Shouldn't be in the technical stuff. Man, I wish I had like a Control F for a book. Technical questions. Here it is. Listen, example, brute force. I guess it's called a brute force algorithm. But there's a word that I'm looking for. It's like, simple solution first, maybe? Like when you break down the problem into its most simple form. Rudimentary. Come up with a blank solution. So everybody, here I have this awesome book, Cracking the Coding Interview, and it has some really good game development advice here. It talks about stating a brute force solution to a problem. So when you're in a technical interview, you start off with the problem and you make the easiest solution possible, you brute force it, and then you optimize as you go. This is what we like to do in game development. When you are faced with the problem, come up with a very simple, easy solution, and even if it's not optimal, you can test it out and you can optimize later, but it's going to get you started in the right direction. Clip that one, right? Sorry, guys. If anybody's watching this whole live stream, good for you. Good for you for sticking around. But I know nobody's going to be here, so I can goof off and act like I'm just recording shorts for myself. But anywho, that obviously there I was like trying to act for the YouTube shorts later on, but the overall sentiment was true. We were going to start off with a very rudimentary, simple brute force solution. We're going to test it out. If we like it, we can stay with it. Like, who cares? Nobody's going to look at our code, you know. And then from there we can optimize. We can make things better. So we're going to start out here by just doing a raycast and seeing if there's anything blocking the player's view. So to the door, right? So we're going to say if inside and inside. So if the front door is open and you're inside, then we're going to do a raycast. We're going to say if physics dot raycast dot this is always complicated, just remembering how exactly to do this. Origin direction. So I think we're going to say the origin is front door dot I don't know if we're going to be able to get the we can't get the transform. Yes, that transform.position. Front door.transform.position. Then we're going to shoot out a ray towards the player. Let's see what the easiest way to do. Yeah, let's just look into our AI.follow here, or our AI follow, because this should make it really easy. Player.transform.position minus that.transform.position. Yeah. So game manager instance player transform position. That's a pretty long one, but we got it. Minus our front door position transform position. We need an out and a range. Yeah, we need a raycast hit. Almost forgot. Raycast hit. And we're going to say out hit. And finally, can we just do that? Yeah, I think we can just do that. So that should be like an infinite, right? We don't need to worry about distance there. And then if the hit dot tag compare tag, right? I thought there was a hit dot compare tag. Hit dot collider dot compare tag. Excuse me. If hit dot collider dot compare tag player, right? Yeah. So if the player can see the door, then our low pass filter dot cutoff frequency equals our outside cutoff frequency. So it's just going to sound like you're outside, right? And otherwise, we're going to do cutoff frequency equals like 1,000, maybe? So it's going to be a little higher than So let's call it inside cutoff frequency equals, no, we don't want to call it inside cutoff frequency. Inside cutoff frequency, door open. We'll say like 1,000. See how that sounds. And maybe we want to lerp it, but not crazy much. I don't know. Let's just try it out first. Sometimes I find it kind of hard to tell you, even just the simple things. So, baby, lay it on you. Baby, just in case you're wondering. Oh, when you get swept away, I wanna swim to your rescue. I'll paddle airward to the stars for you. It's a good song, by the way. I don't remember what it's called. Oh shoot! It's still using the spatial thing. So we need to fix this quick. Can we just delete this one? Yeah, that worked. Oh, and that's for our dark atmosphere. Oh wait. Yeah, that's for our dark atmosphere. I'm wondering if it was getting weird because the two were different, but I want to do this programmatically. Not gonna change on my contradictions. Not contradictions. Whatever. Let's go. Let's schmoove. Let's grab the lantern. Oh, missed it. That's a reset. Yeah, so I think I'm fine with that. We just need to make it smoother, right? So it seems like we're starting to repeat a lot of code in here. If door close animation ready. And we'll just make it like a really quick transition, you know? So let's just grab this code, you know, let's not make it complicated on ourselves. We'll have a little bit of overlay, but it's not that bad. Maybe it is that bad. Maybe we want to make this yeah, we should definitely just make a new method, honestly. Right? But then we want to make it like a coroutine or something so that it's running parallel. Oh, this is so weird. Yeah, I don't know. This is tricky. Oh my gosh. I feel like such a dumbass today, honestly. I probably shouldn't, but yeah, I'm just gonna repeat code. It's too complicated to refactor this, honestly. So let's go for our brute force algorithm, you know? So we don't want to do this, but we do need some sort of a check here. This one's going to be harder to name, so we're going to say private bool. Player is behind, let's say behind cover and at cutoff. Not behind cover and at cutoff. Oh my god, this is so bad. Who cares? Nobody's gonna see this code. Nobody's gonna watch this video. Nobody's gonna go into my source code. It's mine. Okay. Fudging fudge balls. Let's say if hit.completer.compare tag player, then we want to say low pass filter dot cutoff frequency equals mathf.smooth step. Oh my god. We go from outside cutoff frequency to our inside cutoff frequency door open. Behind cover smooth time. And we'll make this one quick. We'll make it like 0.4f or something like that. Let's rename these. Let's call them smooth time. Cool. Now we come down here. So it says if behind cover and at cutoff. What? Yeah. No, we want that to be not behind cover. Wait, no. Behind cover and smoothing. So you're in the process of smoothing. So you're like currently smoothing out the values. Cool. Okay, so we say down here, if you are behind cover and you're smoothing it out, And the time elapsed is less than door time. Door closed smooth time. Cutoff frequency equals smooth step outside to inside cutoff frequency. Door open. Time elapsed divided by our behind cover smooth time. And now we say if behind cover and smoothing. We say behind cover and smoothing is false. Low pass filter.cutoff frequency equals inside. No. We want this to be inside cutoff frequency door open. So it's just going to be a little higher. Time elapsed equals 0f. So we'll reuse time elapsed everywhere pretty much. Let me get rid of this. Else no, shut up, that's not right. Else we're going to take this and we're just gonna change it to the variables that we're using over here, right? So we're gonna say door close animation ready. So this should be if you are looking at the door, then not behind cover and smoothing should be true. No, behind cover and smoothing, which is not true, but whatever, I know what it does. Holy crap. I did not know how to name these variables. Door open animation ready. Okay, so this has to be not behind cover and smoothing. Low pass filter.cutoff frequency equals mathfs smooth step inside. So we're going from our inside cutoff frequency door open to our outside cutoff frequency. No, to our, oh yeah, we want our smooth outside cutoff frequency. That's actually something we want. That should be outside cutoff frequency. Yeah, that's what we want. Time elapsed. Door open smooth time. Not behind cover and smoothing equals false. We're doing it. We're shooting for the moon again, guys. Swish, Kobe. R.I.P. Let's see if we get it. Let's see if this sounds any good or if we break everything. I get the feeling this is going to break everything. I threw that together way too quick. Okay, so it's the opposite of what we want. That's not good. Oh, and that one's going too slow, isn't it? Ha ha ha. Caught part of the bug. But that is certainly not everything. We want to, so if the hit dot, if we see the player. Oh yeah, you're right. We just completely did this backwards. Yeah, we just need to yoink. Bada plop. And then we need to yoink. And of course we need to bada plop. Boom. Bop bop pow pow pow. Save. Come on. Play. Oh. I was holding my breath that whole time. Big tip, do not hold your breath for the Unity editor to work. That's a good way to get hurt. That sounds pretty decent, you know? That sounds really good. That sounds really good, guys. Oh my gosh, I'm excited. I think this stream is over. I think this stream is over, y'all. I'm Outski. I think we did it. I don't think we need any more changes there. I think that sounds awesome. Okay, I know it's not totally realistic. Like, if you're standing right here, it's not going to sound that muffled in real life. But if you're coming over here and you're standing on this table just to prove me wrong, then screw you. I don't want you playing my game. No, I'm kidding. I do want you playing my game. I want everybody playing my game. Even if they hate me. Is that time a little fast? Maybe we tweak that just a tiny bit. I kind of like it being fast. I think we're going to leave this as is, guys. I think this sounds really cool. I think this sounds really awesome. I'm happy with this. I'm super happy. I thought we made that 800. Why is it at 1,000? That's strange. That's a really weird bug. Whoa, what was that? This is why we regression test, y'all. That's not good. Let's see if these are being called, right? Whoa, it should not be if front door. That is super wrong. If front door dot open. Yeah, that's got to be it, right? Okay, let's try this one more time. That definitely probably fixed the bug. Definitely, probably. Okay, so that works. Okay, now let's make sure that this bug is fixed. Oh, did that work? Yes, I think it did. My girlfriend Hannah just walked in. And I think there's nobody better to ask to playtest the changes that I just made.
Sure.
So, today during the stream, we had a whole one viewer. That wasn't you, right?
It wasn't me.
It wasn't you. We had one viewer for like 1 minute and 20 seconds.
Cool.
Yeah, very cool. But what we've been working on is using an audio low-pass filter to make it sound like the storm is happening outside when you're inside. So you can pretty much just test it out if you want. Yeah, pretty much a low-pass filter, like you give it a cutoff frequency and it basically takes the frequencies that are higher than that cutoff out of it. So you pretty much set like a lower cutoff frequency to like when you're inside. Sounds like, you know, it's happening outside. Anyway, just give it a try.
Am I playing here?
Yeah.
Okay.
I'm sorry. You played this game before. WASD. Did you hear the difference?
Oh, yeah.
So when you walk around corners, it should change when you have the door open.
Oh.
So like walk around the corner.
Oh, cool.
Does that sound good?
Yeah, it sounds
And then
great.
try closing the door too.
Okay. Oh, yeah, I heard it there. Oh.
Okay.
Very cool.
Sounds good? Any
Yeah.
critiques?
I wouldn't know what to critique. I think it sounds good.
Alright, get out of here. I'm ending this stream.
Okay. Sorry.
Okay, everybody, for all of my zero concurrent viewers right now, thank you for watching the stream. I'm pretty happy with the progress that we made today. This is something that's been on my list of items to do literally like almost since the beginning of the development of this game, and I just put it off for so long, even though I knew it would be a cool addition. So thank you for showing up. Thank you for listening in. Hopefully you enjoyed and you liked the changes that we made today. Looking pretty good, looking pretty good. So thank you for coming. If you are interested in playing The Perished, go to our channel and you can find our link to our Steam page where you can wish list. You can find links to our other socials, to our website. Get excited for this game coming out in August 2024.